Momjian, EDB's Senior Database Architect, and Kanchan Mohidi, EDB's Cloud Services Director. Now, before we get started, I just want to go through a few housekeeping items. So this presentation is being recorded. We will be sharing the recording along with the slides after the broadcast. The lines are currently muted. If you have a question, please feel free to submit it in the question panel below. We expect the presentation to last most of our time this session, and we will allot any extra time for Q&A. If we do not have time to address all questions, we will follow up afterwards to answer any questions that went unanswered. Along with that, per usual, today our giveaway will be a pair of EDB socks. I know Bruce has his on right now.
All right, there we go. There we go, show and tell. There's the EDB right there. And here's the other one right there. There you go. There it is.
Dream, right?
Yeah, my stock modeling career.
Yeah.
Mark, you look so pensive today. You look like one of those like pictures that they take, you know, executive Mark Linster, right?
Don't forget to get a pair of the socks. Please ask a question below and provide us with the best mailing address, and we will get you a pair of socks as soon as possible. So today, to start off our webinar, we're actually going to start with a poll. Oh, wait, sorry. Before we get to the poll, we're actually going to talk about webinars coming up.
Yep. So it's basically, I mean, this is part of a webinar series, right, that we started a good while ago. So take a look at the recordings. There's a lot more going on. We talked a lot about migrations for the last two webinars. Today, obviously, you know, Postgres deployment with Terraform and Ansible. And then in 2 weeks, 5 things to know about PostgreSQL.conf file. And then in April, or the 1st of April, Devram Gunduz is going to join us to talk about optimizing performance and security with platform native packaging. So, you know, RPMs and Debian packages. So it's a whole series. Join us every 2 weeks here, and hopefully you'll learn something about Postgres. And one thing that you can also add to the question dialogue is if there are topics that you would like us to address, put them in there. We're always open to suggestions. Okay, Molly, back to you.
Yes.
I'm April 15th, so I didn't make it on the list, but I'm the one right after Devram there.
What are you going to talk about?
Window functions. That is the brain busting talk. Remember the one I gave? I think you were there in was Warsaw. Yeah.
I had to hear it 3 times before I got it, but it's really, really useful.
It is crazy one.
So jumping right into our poll, we're talking about deployment targets today. I'm going to launch it right now. The question is, which deployment targets are you currently using or planning to use in the future? I'm going to give everyone a little bit of time to answer before we launch the poll. Right now we have about 25–30% of the audience has voted. We've now hit 50% of the audience voting. I'm going to give everyone another 6–7 seconds. 65% of the audience. All right, we have over 70% of the audience voting. I'm going to give it one more second. And now I'm going to share those results with everyone.
Interesting.
That's very interesting and reflects what we hear from a lot of our customers. You know, OpenStack being very low, OpenShift, in my view, coming rapidly, but still being a very small number of cases. And then, you know, AWS and Azure as the leading cloud platforms getting a tremendous amount of attention, but still, you know, over a quarter focused on VMware-based installations. Thank you.
All right, we'll get right into our presentation now. Kanchan, take it away.
Okay. So thank you, Molly. Thank you, Mark. So today's topic, Postgres deployment made easy. I mean, Postgres is world's most advanced open source relational database with around 30 years of active development and backed by the vibrant community. we saw Bruce, right? He's in a good mood today. Postgres has emerged as a strong, has earned a strong reputation for reliability, data integrity, feature robustness, and performance. But today we are going to talk more about the deployment experience. I mean, we've designed and developed automation that makes Postgres deployment easy, simple. It should be just straightforward, whether it's on cloud, whether it's on premise. That's the goal here. So whether you are a new user trying out Postgres database or you're an enterprise with a lot of Postgres experience, you can equally leverage the simplified deployments that we are going to talk in this webinar. The deployment automation takes care of not only the core database, but also the platform, basically. So it's not just the core database, but along with the database, the tools are also being, the deployment scripts are going to help you deploy the tools as well. So while before we dive in,
maybe just one thing here to emphasize. We're not just going to tell you how smart we are, or especially Kanchan and her team is, in creating these deployment scripts, but the deployment scripts are released under Postgres license, and we will point you to where you can get them and just take them and use them, right? So we're not just going to talk about how it could be done. At the end of this talk, you will have everything to just take these scripts and run them. It takes literally 20 minutes to set up a highly available monitored cluster on AWS or VMware.
VMware based, yeah. So as I'll go through the agenda that we are planning. Mark already mentioned a few things there. So we are going to talk about the deployment platform, as I said, the Postgres platform deployment. What are the popular targets, deployment targets that we see, and so whether the user has an option to choose the Postgres database, whether it's the community Postgres or the EDB Postgres, along with the toolset. So as I said, deployment scripts are going to help you deploy not only the core database, but also the toolsets that are going to help you achieve the enterprise deployment use case that I'm going to talk about, which would have a highly available Postgres cluster along with the automatic failover, and you can obviously manage and monitor it at the end of it if we go using those scripts. These scripts are developed using Terraform and Ansible. So why we went for Terraform and Ansible, we'll talk about that. We'll do a small demo, and followed by that, we'll point you to the GitHub details where you could just go and start cloning the scripts and start using it in your environment. And last but not the least, we'll just talk about Postgres as well as Enterprise DB. What are the various tools and options that we have, and we'll end with the Q&A session. So let's dive in. What we have seen, I mean, this is the list of database deployment targets which are used across the world in all types and sizes of organizations. We have seen both users and customers deploying Postgres in all of the listed environments which you can see here. Let's talk about each of them. I mean, Postgres popularity is growing on Kubernetes, and I think it's a topic for a different and a dedicated webinar. So I won't dive in too much in there. But in the meantime, if you're interested, feel free to go on our website and look for the Kubernetes operators that we have, and it's right there available for you. From there, I mean, in the poll also we saw that virtualization and AWS public cloud were the deployment targets most of you were interested in, or we have seen heavy deployments on that. So that's backed by what we have seen as well. Postgres is deployed heavily on-prem and in cloud environments, be it public cloud like AWS, Azure, Google, or private cloud in your own data center, or in between the bare metal offerings. So they all tie in together. Just wanted to make sure, I mean, deployment scripts that we have developed, currently the version that we have, the deployment scripts are available for the targets, which are the providers for public cloud, which is Amazon at this moment, AWS, and we also have the scripts available for VMware vSphere. Going in, I mean, once you decide that we want to deploy Postgres, so you have an option to choose the open source community Postgres, which has which supports diverse workloads and it has independent community support as well. In addition, you also have an option to go ahead and choose EDB Postgres Advanced Server as well, which has an added capabilities for performance tooling, which has around it, or the enterprise security that comes with it, native Oracle compatibility that we have in EDB Postgres, and also the DBA, basically DBA and developer productivity features. But again, it's up to the user whether he wants to try which Postgres he wants to go about. So we allow the users to choose which database version they want to start with and go from there. The power of EDB Postgres basically comes from its technologies and capabilities that offer flexibility, interoperability, and basically a greater controls for the enterprise customers. Going ahead, as I had said before, the EDB deployment platform is not just going to help you, the scripts are not just going to help you the deployment of the core database, be it Postgres or EDB, but it's also going to set it up with the cluster is going to set up with monitoring enabled, which would allow you to tune or manage the resources. It's going to come with high availability and disaster recovery. So everything is going to come all together, basically. The platform, the EDB Postgres platform, basically was born directly out of requirement of EDB's large enterprise customer. So the tools cover more use cases than the community tools available out there. So you can say it's more of a one-stop shop for best of breeds capability.
I think this is important because a lot of times when I think about automating deployment, you know, your first reaction is, well, how hard is it to deploy a database, right? You just install it and you set some config parameters. But when you start to look at the satellite of tooling you need around the database, right? You've listed them down here really well, and they've all got to work and they got to work together and stuff like that. Then it becomes easy to make a mistake and hard to have a consistent deployment across all your entire enterprise. So the automation always takes time. You know, every time I do automation, it always takes longer to automate a single one than it does to deploy it without it. But on the good side, once you do it once, you get a consistent deployment, and it's really the ability to do that with not only the database but the whole the whole tool set around the database.
Exactly.
And to know that they're all the same and they all are working and the setup's been tested. These are really, really valuable things.
Yeah, thank you, Bruce. So the enterprise use case, basically what the scripts are going to help you deploy is highly available Postgres cluster with automatic failover and monitoring enabled. So how does it take care of? What does that mean? So when you use the deployment scripts that I'm going to demo soon, you can set up not only just the Postgres database of your choice, but in addition, the scripts is going to deploy and configure as well the tools that would take care of the high availability and the automatic failover, and also set up monitoring for the deployed or provisioned cluster that we are going to see. And the architecture, I've just done a small diagram here. You can see on the slide is going to look more like this. So basically, the scripts are going to deploy a 3-node cluster. 3-node would be provisioned on the provider you choose, be it AWS, be it VMware, and the 3 nodes basically is 1 master, 2 standby, and they would have replication set up between the master and the standby nodes. User has an option to choose the replication type, be it synchronous replication or asynchronous replication, or later, I mean, it could be a mix of both, that 2 of the standbys I want synchronous, or 1 of them as a DR site I want it to be asynchronous. So user has all these options where he can input, and input file he modifies accordingly, and the deployment will happen based on the user choices. EFM agent, as you can see, are set up for each of the database nodes and will be responsible for the failover management that we are talking about. In addition, the PEM server is set up, a completely separate PEM server for monitoring the databases that you have deployed, and PEM agents which are running on each of the database node would start sending the data, or start relaying the data to the PEM server. So this entire thing is going to come as part of the deployment scripts that we are going to see. So that's the use case. As I said, I mean, highly available Postgres cluster with automatic failover and monitoring enabled. But some of you might not want to go all the way from having everything all at once. So what we have done is we've tried to make it available in, you can break it down and do in steps. So maybe first step could be that I just want a cluster which has 3 nodes replication setup. So and the scripts are also available as parts of these steps. So you don't have to make, I mean, if you already know and if you want that this is the entire architecture I want to deploy, you can go in one shot. But if not, then we are going to talk about the steps, that how do I go about doing step by step. And maybe I just want failover and I'm not concerned about the high availability part just yet. So that opens up possibilities here. So step 1, as I said, it's going to be Postgres cluster. I mean, test as a test setups, user can test an app using just a single node cluster. But most of the production cases are going to be look more like the diagram we see on the slide here. The cluster would obviously have the cluster is made up of multiple nodes, and the script by default is going to do 1 master, 2 standby. So a 3-node cluster by default is going to be deployed. Obviously, we have an option where user can expand the cluster and add additional standbys later as well. The database option, again, the database that user has an option, as I told you, can choose between community Postgres versus the enterprise Postgres, and we have all the versions from 10, 11, and 12 available for both PG Postgres as well as EDB Postgres. So all the 6 variants would be there, PG10, PG11, PG12, EPAS 10, EPAS 11, EPAS 12. You choose which version you want to start with and go from there. The ongoing data replication needs to happen between the master and the standby nodes. This replication, again, user inputs whether he wants to go with streaming replication, which could be synchronous or asynchronous, or maybe a mix of both, as I said earlier, depending on the use case requirement that the user has. Having multiple nodes would help with load balancing the number of connection to the database. Master takes read-write request, whereas standby would only cater to the read-only request. And for high availability purpose, we have made sure that the master and standby are spread across. I mean, in AWS parlance, it's more like the master and standby are always in different AZs, or it could be in completely different region as well. So step one, Postgres cluster and replication setup, and SR is being set up, and it has the high availability, which is like it's spread across the availability zone. That's step one. Step two, again, how do I add the failover capability for my cluster? Because any production cluster failover is, I mean, high availability is necessary. It's obviously going to, having a fault-tolerant cluster is going to minimize the downtime which is necessary for any production cluster. So that's where EDB Postgres Failover Manager, or EFM, is going to help you. It detects not only the compute network and database failures quickly, but it automatically will promote the most up-to-date standby, and it will reconfigure the remaining standbys after the failover with the new master. So that's being done under the hood automatically if any failover situation happens. So we've seen in the architecture diagram before, the EFM agents were running on each of the nodes, the database nodes, be it master or standby nodes, which are continuously monitoring the database health. And whenever the failure is detected, agent in addition also sends alert emails basically to the email that you have give input as an input parameter. It would send out the email alerts and initiate an automatic failover, which would obviously, if user wants to take some action, it would wait for that. So the way it's going to be configured. So this not only is going to minimize the unplanned downtime for your application, but also is going to maintain you high availability. In addition, having failover manager is going to give you an will also help you have, if required, you can have a switchover capability. What do I mean there? The ability for standby and master to switch roles is required for maybe for some maintenance activity, or you want to patch a database, or you want to do any other maintenance or operating systems needs to be patched. So on those kind of scenarios, you need the switchover capability. And also basically it's going to avoid any split billing scenarios that might come in, and the time lost from triggering any false negatives or unnecessary failures. So again, just to recap, step one was set up the cluster. Step two, make it fault tolerant. Step three, again, it's basically now it will help you monitor and manage the cluster. So if the user wants to manage Postgres database at scale, maybe it's like 500 database instances. So that's where Postgres Enterprise Manager, or PEM, would come for your rescue. It allows you a vast array of monitoring and management features, both for Postgres as well as advanced servers. PEM agents, which we saw in the architecture diagram, are going to collect the performance and status data from the database and operating systems and jobs that are running on the host. So that's all available. That's what PEM is going to help you do that. The data is not only stored, but it's aggregated, and key metrics are displayed in one glance, in one single dashboard. So you can create your own dashboard as well. Alerts can be sent out with a specific thresholds defined in. So that's there. Alerts are sent via emails, SNMP notifications, and obviously it can be integrated with other monitoring tools as well. So I mean, these are going to come in, and in addition, not only the monitoring part, it's going to help you manage the cluster as well. I mean, I want to tune some slow running queries. I want to identify resource bottlenecks. I want to forecast future needs. So PEM has all this separate modules which will help you with the management stuff.
And maybe just to emphasize for those that are not familiar with the EDB Postgres Enterprise Manager, it is built around pgadmin. So at the heart of PEM is pgadmin. So the moment you go through step number 3 here, you will also have connected pgadmin to each one of the database servers that you created in step 1 and then provided high availability for in step 2. So if you want to create tables or create users or anything like that, you will immediately have the tool to do that for the management and then later on for the monitoring and alerting.
Right. So again, just to recap the platform and the steps that we talked about. So basically, the deployment scripts are going to provision the instance or the VM. And when I say, obviously, it's going to be the infrastructure server and also the network storage, all other stuff as well. So that's there. You choose your database from that's the step 1 that we talked about. Then you go ahead, the high availability setup is put in place using Failover Manager. And last but not the least, the PEM server and the PEM agents are configured that would start monitoring and help you with management of the newly set up and provisioned cluster that we just deployed using the scripts. Again, why we went, I initially said in the agenda slides that we have developed the scripts using Terraform and Ansible, but what made us take that decision? So I just wanted to talk about the choices and what factors we considered, and that's what I want to talk in this slide. So all these tools that you can see are used to manage the infrastructure as code. All of them are open source. They are backed by communities of larger community of contributors, and work with many different cloud providers, maybe except CloudFormation, which is very AWS specific. All have great documentation. They have community resources. So how do you decide? I mean, there are, obviously it was, all of them have some positives and negatives. So how do we decide and where do we go from there? So basically we saw that why we picked Terraform over the other ISC tools. It was more of a trade-off, question of trade-off and priorities. So the factors that we considered are mostly basically are around whether it's a configuration management tool or whether it's a provisioning tool. I mean, Chef, Puppet, Ansible, SaltStack are all configuration management tools, which means that they're designed to install and manage the software on the existing server, whereas CloudFormation, Terraform, again, provisioning tools, which mean they are designed to provision the server themselves. Again, not only the infrastructure, but again, databases, networking, configurations, and other stuff. All the blocks are put together, are provisioned as part of it. So that was the first thing. Second was how easy it is, whether it's a procedural take or a declarative kind of language. So we know that Chef and Ansible encourage a procedural style where you write a code that specifies step by step how to achieve that end desired state for your infrastructure. Whereas the tools like Terraform, CloudFormation, SaltStack, Puppet all encourage more of a declarative style, where you write the code that specifies your desired end state, and IIC tool itself is responsible for figuring out how to achieve that state. So maybe you started provisioning like with 5 clusters, and later you want to change it to 10. So just changing it to 10 Terraform or Ansible, Terraform or CloudFormation knows that, okay, 5 is already provisioned, so it just goes and adds a next 5 to take care of the deployment that I asked for it to take it to 10. Whereas in a procedural language, I have to make sure that I update it, it loops through, and then it goes and have that knowledge. So that was one thing. Again, the third point that we thought of was by default, Chef, Puppet, SaltStack all require that you run a master server for storing the state of your infrastructure. And then from there, it starts distributing the updates. So master server can obviously revert the changes to prevent any configuration drift. But then there is an option available with Ansible, CloudFormation, Terraform. They are all masterless by default. For example, I mean, Terraform communicates with the cloud provider using directly the cloud provider APIs, or Ansible works by connecting directly to each of the server over SSH. So again, do you want an extra master to take care of the states, or you don't want that in place at all? So that was one of the points. And next one was whether the infrastructure is mutable or whether it's immutable. So configuration management tools such as Chef, Puppet, Ansible, SaltStack typically by default has an immutable mutable infrastructure paradigm. So what does that mean? So if you tell Chef to install maybe a new version of OpenSSL, it would run an update on your existing server, and the change will happen in place. So over time, the more and more updates you're going to apply, each server is going to start building a unique history of change. So this phenomena, as most of you know, would lead to the configuration drift, where each server becomes slightly different from all others, and then managing it all together, it's difficult and leads to a lot of other issues. Whereas if you're using provisioning tools like Terraform to deploy, machine images are created, be it by Packer or Dockers, and then every change is actually a deployment to a new server. So when I say that, what I mean just taking the example of OpenSSL. Basically, now if I want to deploy a new version of OpenSSL, it's not going to upgrade in there. It's actually going to create a new image using Packer or Docker, and then deploy so that on a totally new server, and undeploy the old server. So this would minimize the configuration drift that we spoke about. Again, one of the factor was considered that, okay, some allows you to have an agent running, or some are agentless. So Chef, Puppet, SaltStack all require you to install the agent software on each of the server that you want to configure. And Ansible CloudFormation does not require any extra agents. So there are other factors as well, but just that to make sure everybody knows what you need to think about when you talk about deployment tools or infrastructure as code. There are the factors where whether it's supported by a community, whether the community is large or small, whether it's a mature tool or whether it's a cutting edge technology. So considering all this, we decided, or we implemented using, as I said before, it was Terraform and Ansible, where Terraform does the provisioning part, and Ansible would do the configuration management of the cluster that we just deployed. So when I say Terraform is going to be that orchestrator, it's going to talk to VMware and AWS and deploys the infrastructure, and then it basically it will stand up your virtual machine or cloud instances, and then we hand over the reins to Ansible to finish off the configuration of our Postgres database. or setup tools like the Failover Manager for high availability, and Postgres Enterprise Manager or PEM for monitoring the cluster. So that's how we went and deployed created the deployment scripts using Terraform and Ansible here. Going ahead to the demo part, I'm just going to switch my screen. Mark, let me know if if we are not able to see my screen properly. Can we see my?
No. Yes. Yes.
Okay.
The screen works properly.
So once you clone the deployment scripts, they're going to look something like this, as you can see on my screen. As we mentioned before, the provisioning scripts are available for two providers, AWS and VMware. And the folders here specifies the steps that we talked about. So if I want to just deploy a cluster, I go into the DB cluster AWS. Again, the same option is available for VMware. For EFM setup, this is the folder. I go in, I do Terraform init, and then apply. I'm going to show that. The monitoring setup, again, PEM server, PEM agents, separate. So the steps that we spoke earlier, those are exactly how the scripts are available to you. So you can go ahead and do step by step, or we are going to make one single option available that you just say that deploy Postgres platform, and it will do an entire thing end to end for you. So let's dig in details. So I want to go ahead and look for the AWS thing. Before that, I just want to show you the details so that you're familiar with the setup. The README file has all the instructions, and the input file where the user has an option to choose the input parameters and also input some of the configuration of the setup, whether it's VMware or AWS, the AWS accounts, ID, password, the SSH key. So all those fields that is very unique to your own setup, those you want to input in this file. This is your input file. Again, in the file itself, we have made sure we have listed down which are the mandatory fields you need to input in this config file for it to run, and also what are the optional fields or where we have used the default in those optional fields. So again, credentials, which database user you want, where do you want it to, which Postgres version you want. So basically, this is the file where it's going to accept all your inputs. I'll quickly take you through the README file as well. I mean, with Terraform, you have all the details in the README. Those who know Terraform, you all know that it's pretty straightforward. You initialize your infrastructure, you do a Terraform init, and the plan is basically, before it actually goes and connects to the provider, it's going to show you what the plan is going to show you, that how many nodes are going to be created or what's exactly going to happen. It first displays that output, and if you agree or if you see that, okay, exactly, this is what I want, just do a Terraform apply, and it's going to be right there available to you. So the README has all the instructions, and in addition, if you still need a step-by-step guide, we have made available that as well. So doing that in the essence of time, I mean, it's just that you do a Terraform init and check initialize it, and from there the next step is going to be Terraform apply. So in the essence of time, I had already completed the Terraform apply part of it, so that we can cover all the steps.
So Kanchan,
yeah,
Kanchan, how long should somebody expect that this will take? If they say, okay, create this cluster as you described on Amazon, just the basics of the streaming cluster without EFM, without PEM. Is this like a 5 minutes, 5 hour, 5-day operation? How long does it take?
It should not take you more than 5 to 7 minutes, Mark. So this is the step one that I had chosen EPAS 12, and it output me that, okay, this is my SSH key to log in. This is my master that it spun up on my AWS account, and these are the standbys that I can see here. So, I mean, I can quickly get into, I've kept my console as well ready to see how it went and created my instances right there. So why, okay.
That's the demo effect. How many donuts did you sacrifice to the god of demo this morning?
No, I would need to sacrifice the donut to myself. But yeah, so as
That's
you can,
a mistake.
Yeah, so EPAS, it not only created the master and standby, so a 3-node cluster by default, as I told you. I mean, I just did the default thing, and it has set up the PEM server also for me. The scripts have done that. I haven't done anything here again. So coming back, I can obviously use my master IP and SSH into it. Okay, I tried that before, so I mean, this is so this is my IP as we saw 172.33.172. That's exactly 172. So it's all set up. I went in. Oh, sure. Okay. Is it better now?
Yeah, it's good.
Okay. So I'm just going to check. That's the server. That's the EPAS 12 cluster that we set it up. Again, it's just the Postgres database that you're used to. So you can start creating tables, put in data, okay. So maybe test one, insert into. I am just making mistakes typing. Okay, great. So there you go. And we can obviously check replication stat, as I said. I mean, are my slaves being set up correctly? So streaming replication has been set up. It's all ready to go. So that was our step one, replication setup. We saw the Amazon cluster. Similarly, I mean, VMware also, I made sure that for demo purposes, I had tried to set it up. So again, for VMware, it's exactly the same thing. You just go into DB cluster VMware, input your parameters there, input your data center name that you have, your application password you need. So basically all the customizations you're going to need for your VMware setup, that's all in there, and it would just take it from there. Similarly, I mean, I just want to quickly make sure that the PEM server that we set up, I had put it on the background for us to take a look. So once that is being set up here, I would just use the same 217.117 that we saw. That's the one we created. we'll just log in into it. And while it is spinning. So as I said, I mean, not only the database, but now you have the monitoring software being deployed, and it's going to help you. I mean, it's saying that the 4 agents are all set up, and the 4 servers, that is my 3 nodes database, master and 2 standbys, and the PEM server itself. So everything is right there on the dashboard. You can see everything, and from here you can then start configuring or start, how do you monitor, put in alerts, thresholds, what do you want to do with your Postgres cluster. It's at your fingertips now, and you didn't have to bother about the deployment at all. It took care of it seamlessly. And last but not the least, I mean, I had logged in into so on the master again, if I do the EFM setup, which is what we are going to see now, which I've already done, we can just go and see here. Sorry. So again, failover manager is all set up with all the default parameters. If you want to give any config parameters for based on your requirement, you can always do that. And the EFM cluster or the failover manager that we spoke about, that's also been set up for this deployed cluster. I think we're going to take the questions at the end, right? Okay. So in the essence of time, I will switch back to yeah. So again, you saw the demo. It's pretty straightforward. Once you know the steps, just go into that folder, do a Terraform init and a Terraform apply. And if you have inputted all the input parameters correctly, it's just going to deploy the platform that we spoke about. So, I mean, the takeaway that I want you to remember here basically is that the deployment of not only the server, but the entire platform is straightforward. It can be done in few minutes, as Mark said earlier. What's coming up next? Obviously, I mean, we are looking for inputs, user inputs, but this is what we have already done. You saw that along with the database, the high availability, and the monitoring pieces. Next, what we plan to add is the backups, where it would take care of the deployment scripts will automatically take care of the backup, set up the backups and stuff for you. And followed by that, what we want to do is take care of the logical replication piece. Mark, you want to add something here?
Yeah, this should all happen over the next couple of months, and I think Constant will point you now to the GitHub repo where this information is available, and so get us feedback there, and follow what is going on, and you'll see as new versions become available. But our plan is definitely to automate this way the whole EDB Postgres platform, and make deployment really easy. And as you'll see when you run this in less than 20 minutes, you'll have a highly available monitored and managed Postgres cluster available on initially Amazon and VMware, and then after we've extended the platform to cover those completely, then we will move from there to Azure and Google, and potentially also OpenShift. And again, provide us feedback, see what should be the next targets.
Right. And I mean, here, as I said, GitHub, it's on Enterprise DB. Just look for Postgres deployment, and it's right there. Again, if you just clone these repos, these are exactly the folders that I've shown you. So once you download, you clone it, it's right available. Just put in your inputs and get it going. If you still think that I need some help, so we have a wiki page where all this information, the step-by-step guide, everything is available for your reference. If not, I mean, we are monitoring. So make sure you leave inputs. You have any questions, we'll try to answer them and get it available for you. So that's about the demo piece. I'll hand it over to Mark.
Okay, sure. I'll be brief because we've run a little long. So I'll be really brief about Enterprise DB and EDB Postgres. So let's just move forward here. Kanshi, please. Okay, just for everybody to know on this webinar, one of the reasons why we feel very good about publishing these scripts is because, we've been doing this for now over 15 years. For 14 years, we've been active Postgres contributors, and the company has been around working on Postgres for 16 years. So that's also the reason why EDB Postgres is in the Gartner Magic Quadrant, because we've been doing this for a lot of large companies around the world, and a lot of what we're pushing for is to give everybody everything they need to get the maximum value out of Postgres, because obviously we're biased. We believe Postgres is great, but as Bruce said before, you do need additional tooling for high availability, backup, recovery, monitoring, logical replication. So there are additional tools that need to be added. Today,
Sorry.
and again, this is fine. We're working with over 4,000 customers worldwide, lots of them large companies. Bruce and I work with a lot of them personally, Kanchan the same way, so we know they don't use Postgres for trivial applications. And again, that's where our knowledge and our certainty about these scripts come from. It's because we've done it a lot of times, and we've taken a step back and said, hey, this can be easily automated. There's actually a reproducible, reusable pattern here that goes forward. And, that's how you should look at these scripts. They're not just, we didn't just invent them. This is really something that has been proven in practice. Forward. Okay. And then we're very active in the open source community. So we're not just commercially active with Postgres. Bruce, who you see here, is one of our team members, has been driving our effort in Postgres forward for a long time, and has been the engine behind the very successful Postgres community now for, I would say, over 20 years. Dave has been with the community for over 12 years. Robert, Amit, Devram, all names that anybody who works in Postgres or follows the hackers list closely knows very, very well. And then we're also active in adjacent communities. For example, Akshay Joshi and Ashesh Vashi are very active in PG Admin. Many of the other names here that you see, like Rusha Bhatia, for example, are very active contributors to the core Postgres project. Let's go forward. So all of this, I'm mentioning this so that you understand where the context is for us to create these scripts, because we do it for a lot of large customers. We've done it hundreds, if not thousands of times. So we feel very good about taking many years of expertise and wrapping it into these scripts, putting them out there, as I said, under Postgres license, so you can just take them. We'd love if you provide us feedback, if you give us improvement ideas, etc. But they've really been created because we have the expertise. If you want to know more about us, get in touch. We offer lots of tools around Postgres that we believe are necessary to get the most value out of it. We have a great services team. and a really good support organization, which is another thing that is essential if you want to get great value out of Postgres. Postgres is extremely reliable, but having somebody that you can work with in case things go bump in the night, or in case you have a hard question about Postgres, is important. Go forward to the questions then. Okay. So Molly, I'm sure we get a bunch of questions, so we get a few minutes that we could spend on answering questions.
Yeah, so we have a couple of questions that came in. We'll get started right away. So the first question we got was, how do I get EDB tools, which were spoken about as part of the EDB platform?
Okay.
Okay, we can go forward. Yeah.
Once you download the scripts and you want to go ahead and use the EDP platform, just register on our websites, and the Yum credentials will be made available. Use those in the input file that I showed you, and you should be right there.
Yes, and then so they do come with I think a 60-day trial license, so you can just use them. I mean, the trial is the same as the production version. There's no difference. And then you can try those for 60 days. Obviously, after that, we expect you for the tools to become a customer. And then you can just continue using them, use your credentials. But the credentials, you literally get them within 10 seconds of going to the website.
Yeah, and the wiki page that I showed you how to get the Yum credentials, there is a step-by-step doc as well. So if you feel that I'm not sure what I need to do, it's right there. I mean, all the instructions are right there.
Great. Another question that we had come in was, is it supported to use EFM with a community edition?
Correct. Yes, it is absolutely. All the EDB Postgres tools support the community edition just as well as advanced server. So whether you use Postgres Enterprise Manager, the Failover Manager, the backup recovery tool, or logical replication, or the foreign data wrappers, and I'm sure I'm missing some things, they all support PostgreSQL and EDB Postgres.
All righty. We have time for one more question before we use up all of our time. And that question is, what are the other deployment targets that are in the works right now?
Well, we'd love for you, but first, the survey gave us some pretty good indication that our initial targets were right? I mean, the highest occurrence was AWS, followed by VMware. So we're glad that we're covering those. And after that, we'll probably go to Azure and Google. So, but if there's other ones that you feel strongly about, just plug them into the chat, and we'll take that into consideration.
All right, great. So that is all the time that we have for today. I apologize for those questions that we were unable to get to, but this is all the time that we have. Thank you for joining us for the webinar. We will be sharing this recording along with the slides with you as soon as possible. I hope you all have a great rest of your day.
Thank you.
Thanks.